About the Green-Ampt equation that you'll be using for this week's problem set. So this is a really important equation for understanding how moisture infiltrates into soils. And we'll be going over and deriving the equation in class this week, but you don't need to see the full derivation in order to start to get a hands-on understanding of how the equation works, how different soil properties or rainfall characteristics influence infiltration rates. You can do that by exploring the sensitivity of these properties in a Excel spreadsheet similar to what we did with the Penman-Monteith equation. So I'm going to show you how that works. This is relevant for questions 2 and 3 in the homework assignment this week. So let me go over now to the Green-Ampt Excel sheet. So just like last week, you're going to put input data in on the yellow cells and get calculations out in the green cells. So there's some relevant soil properties like porosity. So downloading the spreadsheet, it's just going to have some values in. I'm going to change that a little bit. Let's say our porosity is 45%. So that's how saturated our saturated water content could ever be. This is the air entry suction head. I'm just going to change that a little bit too. And then this is your saturated hydraulic conductivity. We'll talk about that in class today. I'm going to lower that a bit. The next rows down are the event characteristics. So this is your rainfall rate. So I'm going to make it rain about 1 inch an hour for 4 hours. This is your initial water content. Let's just leave that the same. Okay, so now there's some green cells that you don't want to do anything with. And then down here, there's this long table. And the columns on this table are the cumulative infiltration, so the total amount of water that has infiltrated at any given time, the infiltration rate that is occurring at any given time, and the depth to which the wetting front has reached at a particular time. So how far down has moisture from that rainstorm made it into the soil at a given time here? So what your assignment asks you to look at is the time of ponding. So how long is it into the rainstorm before that soil can't infiltrate all of the rain that it receives? And you can see that right down here on row 24. So it says time of ponding right there. It says it occurs at 0.277 hours for the soil and the rain that we gave it above, at which point the wetting front had made it 4.7 centimeters into the soil. And here you can see that the rainfall rate was 2.54 centimeters per hour. But remember, our saturated hydraulic conductivity up here was only 0.36 centimeters per hour. So if it's raining harder than the water can move through when things are saturated, that means ponding is going to happen pretty quickly. And that's what we see in the output down here. The next thing your assignment asks you for is some characteristics of infiltration that are occurring at the end of the storm. So in your assignment, the storm ends after 3 hours. In this example, we're going to make it end after 4 hours because that's what I put in up here in cell G10. So if we want to know what's happening at 4 hours, we need to look in the time column here for a time at 4 hours. But what you can see is we don't have anything right now. So we can go over to these yellow cells and start to play with them until we produce a time of 4 hours. So we know it's going to take more than 4 centimeters of total infiltrated water, but less than 5 centimeters. So let's just go with something like 4.2 centimeters. Okay, that's less than 4 hours. What about 4.4 centimeters? Ooh, that's really close to 4 hours. Now we're at 3.956. So let's try something like 4.45 centimeters. That gets us a little bit over 4 hours. If we want to really hone in on 4 hours exactly, we can try to play with that a little more. 3.998 hours. I think we can all agree is pretty close to 4 hours. So if I want the infiltration rate at that time, that's this column E that says, or excuse me, the infiltration rate at that time is column D. That says that it is infiltrating 7.07 times 10 to the negative 1, or 0.707 centimeters per hour, or 7 millimeters per hour at that time. And the depth of the wetting front is 29.5 centimeters. So those are the answers we'd be looking for this soil. You're going to want to note those answers in someplace that you're not going to write over them. So I'm just going to say time of ponding, infiltration rate at 4 hours, and the wetting front depth at 4 hours. Copy things over before I change anything else about my soil or my rain. So we had an infiltration rate of 0.707 and a depth of 29.5. And now I'm ready to go on and change something about the soil. So let's say that we're going to double the rainfall rate up here in cell D10. And what happens? Okay, so in our second case, we see that our time of ponding gets much shorter, so 0.066. But now we need to go through that process again and find our 4 hours. And it's actually not too different in here because we haven't changed anything about the soil itself, just the initial time of ponding. So we can continue to kind of work our way through these things. Oh, well, it's a little bit more, isn't it? Okay, so now we're back to 3.998. After 4.5 centimeters of total infiltration, our wetting front depth is now 30 centimeters, and our infiltration rate is 0.701. And so you could repeat that. You can vary any of the things that are up here in the yellow, but your problem set gives you some specific things to look at, some specific soil characteristics, and some specific rainfall characteristics. And then you're going to present that data either in a table for question 2 or by making tables or graphs and writing some words for question 3. All right, that's it for the Green-Ampt spreadsheet. Hopefully that's pretty self-explanatory, and I will see you in class soon. Bye.